Hi guys, welcome to another one of RG Diode lectures, and today I'll just be briefly giving you an overview of the semiconductor diode. Now before we get into the nature of a diode, let's talk a little bit about a semiconductor. So semiconductors can occur naturally, like silicon and germanium. We call those pure or intrinsic semiconductors, or we can create them through a process of doping, and those are extrinsic semiconductors. Now, semiconductors are categorized as materials having an intermediate conductivity. That is, they are more conductive than an insulator, but they are less conductive than a conductor themselves. Now, the use of those materials allow it to function in a diode capacity. So a diode is a device which simply rectifies a AC to a DC. AC stands for alternating current, and typically when the polarity of a source changes, the direction in which the conventional current will vary. So because of that, you have that change in direction, right? From, we can call this positive to negative cycles, is indicative of an alternating current. Correspondingly, direct current don't dip below a certain x-axis. So you would find that you have a flat line if it's a battery, which indicates a relatively constant voltage flow. Or you can have here where you can have a slight ripple effect. Nonetheless, you can talk about a diode being a device which converts one to the other. And what it does is that it allows the device to function in two modes of forward bias and reverse bias, and that is how the rectification process occurs. Now, if we examine the typical symbol for a diode, we see that it is a triangle with a line. Now, the triangle is representative of a certain type of semiconducting material called a p-type. P stands for excess positive charges or holes. The line represents an n-type, and it is indicative of having excess negative charges. Now, when you merge these two types of materials together, you can get a diode functioning in forward bias mode. So the p-type is connected to the positive and the n-type is connected to the negative. Now you might say, okay, but what sense that makes if p is positive and you hook it up to a positive potential, and then n is now excess negative charge and you hook it up to a negative potential? What you would have found is that the like charges at the ends of the diode repel each other. So now they are forced to leave the ends of the material and they are forced to cross the p-n junction. Now the p-n junction is where the two materials are merged together, and you would want the electrons to cross over and come to the holes, that is, be attracted to the holes, because you would want to stimulate the flow of charges, which is, in other words, a current being generated. So when you have those like potentials connected to the p and the n-type material, it forces the charges now to cross the p-n junction, and that generates a flow of charges or a current. So the negative charges, I know that typically when I taught you electricity, we considered the movement of a current as the movement of positive charges or conventional current. But if you think about it logically, because of metallic bonding, you have free and mobile electrons, and it is these charge carriers that will now move across more easily compared to the positive charges. So nonetheless, the negative charges are going to be attracted to the positive holes, and it causes that circulation. So as the negative charges go to the left and they flow, it gives the effect that the positive holes move to the right, which is, in other words, the flow of conventional current. So if now we convert it to forward bias mode, we are saying that in forward bias mode here, I will tend to have now in forward bias mode, I will tend to have the opposite charges becoming attracted, because I'm now hooking my p-type to the negative and my n-type to the positive. So now opposite charges, because the p-type holes, positive charges, will be attracted to my negative potential, and the same happens with my n-type and my positive potential. So you find that the flow of charges across that p-n junction decreases drastically, and it results in a widening of the p-n junction. which is what we call a depletion region. Now here in reverse bias, you find that you have a graph, a typical IV graph that is representative of that characteristic. Now in this part where you have a drastic increase of current with voltage, we consider that the forward bias mode, because it's highly conductive. In the same way, in reverse bias mode, where you are limiting the flow of charges across that PN junction because it's now functioning as a depletion region, you have a minimal amount of current flowing. And that is what we say as a reverse saturation current. Now, in my typical circuit, what you will find here is that you will have a diode, right? And you will have your AC supply. So you will find that your positive charges, let's look at the the yellow line. The green is just a circuit. You must have an AC source. So you cannot have, and this is a popular question in multiple choice, where they show you your source, but for you to have rectification, you must have an AC source. So when you hook it up to your diode now, you will find that you will have the P type as positive, your N type as negative. And you will find that it functions in forward bias. So you have conduction here. Right? Now, if you switch the polarity, your current now goes in the red. Right? So then your diode will function in reverse bias, where the N type is now connected. So this is positive here, and this is negative, right? So now the N type is connected to the positive and the P type to the negative. So that results in no current flowing. So now in my half wave rectification graph, whenever you would have had this negative half cycle here, that will now be where the diode is functioning in reverse bias, and it would simply cause no current to flow, or your reverse current goes to 0. So in half-wave rectification, you have your diode conducting, not conducting, diode conducting, not conducting. And as it switches from one mode to the other, it basically results in like your current flowing. So it's like switching on and off state.